All right, here we go. We've got rational exponents. This just means that the exponent here has a fraction in it rather than a whole number. So the opposite, or a non-rational exponent, would be something like, let's say, x squared, because it does the exponent is a whole number rather than a fraction or a decimal. But we're really going to look at rational expressions in this particular unit. So when we have something like x to the power of 1/2, this really just means that it's a radical. So it is a radical like that, and on top of the little the ledge here, there's a 2. So it's not like multiplying by 2, but it's just sitting on the little ledge. So that's where the denominator goes, and then the thing that's being put to the power goes on the inside. Again, we have something like x to the power of 1/3. Instead of having a little 2 there, there's going to be a little 3 that sits on the outside. And this is called a cube root, whereas our example up here is a square root. And this is just the long way of writing. I should have said this before. This is the long way of writing the square root of x. When there's nothing there, we assume that it's a little 2. This last problem on this page, x to the power of 1/33, this is just to kind of give you an idea that, hey, these are all kind of have the same outcome, is that the denominator sits out here on the outside and we're left with this. Now, we could have something a little bit more complicated like x plus 4 to the power of 1/4. And in that case, the stuff inside the parentheses all feels the impact of that 1 to the power of 1/4. And since there's an addition sign in between, we can't really simplify this by distributing, because that would kind of ruin the impact of having that addition sign. So what we have to do is we draw a radical symbol. Our little 4 sits out on the side, and what goes inside is the stuff in the parentheses. So x plus 4. I don't expect that you'll see very many of these, but when you approach calculus, you'll really need those rational exponents to help you. When we have something in the exponent that is more than, this isn't just like 1/3, in this case it's 2/3. So first I'll give you the longhand version of how to approach this kind of problem. The longhand version being, we use the exponent rules to break this up. To get this, it's a multiplication, so to undo it, what we essentially need to be dividing the exponent. So this is really x squared to the power of 1/3, because 1/3 times 2, 1/3 times 2 gets us that 2/3. So I reverse multiplied these. I kind of went backwards. And this is some of the theory behind it. So now you notice that our most outside function is that 1/3. So I know that I'm going to have a cube root. I've got a cube root there. And what's inside the parentheses? Oh, that's the x squared. Again, we've got 4/9. Some people want to, here, we'll talk about the shortcut. The denominator will sit on the ledge. So in this case, the 9 is going to sit on the ledge of the radical. That squiggly thing is called a radical. And then what goes inside is x to the power of 4. It's left behind. Someone asked me in class the other day, I noticed that 4/9 can be reduced. Yeah, you can totally reduce them, and that will get you a similar answer. 4/9, both the top and the bottom. Well, rather, it can't. Never mind, I digress. We can apply this again. Just one more example. If I had the denominator sits out here on the side, and what's left is x to the power of the numerator. Let me add one more problem here, because I think it's going to be valuable. If I had like x plus 1 to the power of 1/2, or let's say 2/3, I like that a little bit better. We start building this. I have a radical. my denominator sits here, and what's left over, all the stuff in my parentheses, x plus 1 to the power of 2, and then that's the end of our, that's the furthest we can simplify this into a radical.